Hey, what's up, Blue? Okay, cool. Let's start. Sorry for the bit of waiting. I usually wait a couple of minutes to wait for people to come because they're usually late. So thank you for all coming tonight. Super cool. Maybe we're gonna have more people. I've seen a lot of people asking for the broadcast, so that's really great. So So my name is Adrian Cadet. I work as a mobile developer at Lyft. I've been a regular teacher, like I talked about, like maybe a dozen of classes now. So the topic of tonight is not going to be about Ruby itself. It's about like more that the examples I have today are going to be in JavaScript. But this is actually this concept I'm going to talk about tonight, like reactive programming, is actually existing like any languages, any language, sorry. So also feel free to interact with me tonight. Usually my classes are like pretty interactive. I expect people to ask me questions. And I'm a little bit slower than usual, so feel free to stop me if you don't understand anything. Also, is it the first class for anyone tonight? Is that the first time you're coming here? Cool. What's your name again, Zach? Alex, no, sorry. Cool. Why did you come tonight? Why did you come tonight? Just for this class, or like you're interested in more? Okay, cool. Nice. Also, if you don't know, like Red School is a non-profit organization, and we do not accept donations actually, but feel free to make donations to Noisebridge instead, who are super nice to host us tonight. Cool. So yeah, so tonight I'm gonna talk about reactive programming. So I was saying it's like existing in multiple languages. It's not something new, but I mean it's not a new concept. But some recent tools, especially the one I'm gonna talk about tonight, Reactive, like started the trend again, and also more recent tools such as like Redux are using the same system. So if you were like thinking of like using Redux and you don't understand what's happening, this class will teach you the basics, and then you can do whatever you want. Cool. So before starting the presentation itself, does anyone, I mean, have like idea about what we might talk about tonight? Like what, basically, if I say reactive programming to you, what do you have in mind? Like, that's something you don't understand at all, or do you have like any idea what I might talk about tonight?
I don't know what it is. I think it's a framework.
You think it's a framework? Okay. Reactive is actually a library, but reactive programming is like a concept. It's like you have functional programming, for example, imperative programming. So reactive programming is just like a concept. Cool, but it's a good point. Anything else? Anyone like reactive? Like, I don't know. Maybe basically any idea of what might happen in the hood or anything like that?
I think it's just like I haven't used it, but I think it's along the lines that it's kind of like having a description of observers where you can tie certain variables or certain whatever objects in the program. So when one changes, another one knows about it and can react to the changes.
Yeah, exactly. So that's thank you for that, Jamal. So basically, what's happening is like you have an option indeed of like observe, like source of data you can observe, and an option of subscriptions as well, and also like events. Of course, you get to emit between these two actors. So basically, yeah, the two main actors are like the subscriber and the observable. So to make it simple, the subscriber subscribe to a source of data, something that he can observe, and this observable will emit notifications, maybe a single notification, maybe multiple of them. For example, a good, what you can think about is like when you're watching TV. So TV is like the TV channel, let's say CNN is like an observable, so it's like broadcasting, and the subscription is like when you turn on your TV. So, you know, I guess you know that, of course, but CNN is like broadcasting no matter what, you're like, you know, your TV is on or not. Like, you are basically, when you're turning on your TV, you are like subscribing, not like a subscription or like a plan subscription like a cell phone, but you're like subscribing to the TV channel, you're watching the TV channel, and like the notifications are like the different frame that the TV channel is sending to you, and your TV will reconstitute, of course. And then as soon as you are like tired to watch TV, you just turn it down and you unsubscribe from the observable. Does that make sense? Cool. So what I was saying before, it's not a new technology that I've been here before, and especially if some people here did some C# before, it was like the main thing in their NVVM pattern. So for people who don't know, NVVM stands for model view model. And let's say in C#, let's say you build like a Windows application, and you have in your UI you get to render a list of users. This UI component that is in charge of rendering the list of users will be hooked up to a list of users. And as soon as in the code you update this list of users, the update will be propagated like automatically. Like you don't have anything to do. You don't have to refresh the UI. The UI will be refreshed for you because it's the way it works in C#, thanks to what they call view model. So view model is like the special item. So it's either like the list or like just a single object. You update, and it will like automatically refresh the UI for you. It will publish the update and then refresh the UI for you. And also you can see an observable as like it can emit like a single notification, like an asynchronous call. So like let's say in JS, when you do an asynchronous call, it's kind of like an observable. So you run like you fetch it, let's say your own server, or you fetch something else like an API, and you basically waiting for notification on completion, like on error from this remote source of data. So the observable is like the source of data you're trying to reach, as I was saying before, the server of the API. And your subscription is like your JS code that is waiting for this notification to come. Okay? So an observable, so here it's like I'm going to talk about the, let's say the rules, so like what the pattern should look like. So this pattern would be the same in like any kind of languages or like frameworks. So we're talking about emitting notifications or events, the same stuff. So you have three kinds of notifications we're going to talk about just after, which are on next, on completed, and on error. So before talking of V7, so you have two notions about observables. So you get to understand there can be either hot or cold. So hot is an observable that is already existing and emitting notifications before you subscribe to it. So for example, it could be seen as a continuous stream of data. So before I was talking about the TV. The TV is a good example. You turn on the TV, you're watching CNN. CNN was broadcasting before you turn on the TV. CNN is not waiting for you for broadcasting for you, like turning on the TV. So that is an example of a hot observable. So you're subscribing, it's already emitting notification. Maybe you're the first one to subscribe. That happens sometimes, but mostly, let's say you are not the first one. And so I was saying it's either hot or cold. So cold is just an observable is waiting for subscription before being run. So the perfect example is an asynchronous call. So an asynchronous call before you subscribe, like before you basically start the asynchronous call in your JS code, nothing will happen. Like this asynchronous call is not run like just by magic. It's just waiting for you to like run it. So let's say you want to fetch something in the background, or like a Ruby application, you want to read a file and like do something. Usually it's like you use a call observable. So you have an action waiting in the background to be run. You subscribe to it, the action is run, and then this observable emits like a notification, like the action has been performed correctly, and you can proceed to something else. So hot or cold? Is that okay for anyone? Like the difference between hot and cold?
Can you say the last two words you said? Hot and cold, is that what you said?
Yeah, hot and cold, yeah, sorry. Also, you get to think that an observable might trigger events even if there is no subscription anymore. So let's say if you define an observable that fetch a file from a different server and like do some operation on the file and then return the outcome or something like that, even if like let's say as a client you subscribe to it and then you're like, oh, I don't need it anymore, so I unsubscribe. By default, an observable keep running, so it doesn't cancel the operation for you. It just like keep running, and then when it's like over and ready to trigger the notification, it will just figure if there is any more subscriber or not. But by default, an observable is like, it's gonna actually trigger the event on the subscriber, but the subscriber will not be notified because you unsubscribed before. And also for something not really important in JS, but in other languages where you have multiple threading, you can define usually whatever thread you want to run the observable on. Usually, let's say you do a mobile application, you might want to run a long operation in the background because you don't want to block the UI thread to, I mean, you don't want to freeze the UI to like run something. Yeah. So we said an observable, no, a subscriber. So subscriber, as we said before, is observing a stream of data. So it can be stream of data, of course, can be sometimes just a single event, but it's still, we're still talking about the stream. And usually you might see also it's like name an observer, but it's better to use the word subscriber because observable observer is kind of like tough sometimes to know what we're talking about. So usually when you subscribe to an observable, defining you a subscriber, the tools you're using are like returning a subscription to you. And this subscription is this object you will use to unsubscribe at any time from this observable. So let's say you sign up to T-Mobile, like they will provide you like a way to unsubscribe later. So let's say T-Mobile, it's the observable, you are the subscriber, and they provide you a subscription that is usually the contract or whatever, and you can unsubscribe whenever you want. Depends, but let's say whenever you want. And also for what I was saying before, for like languages with multi-threading, you can also define different threads for like the subscription. So you might want to run something in the background that you want to observe the result of, or like the notification that your observable is emitting on a different thread. But that is maybe a little bit too advanced. That cool so far, observable, subscriber, awesome. So I was talking about the events. So now, what kind of events can an observable emit? So you have actually, it's very simple. You have only 3 kind of events. So the one you might think about right now is what we name onNext. So onNext is like, let's say you observe something that is supposed to return you a file. onNext will be the emission of the file. So it would be like, let's say if you subscribe to it, like you will pass a function that will accept as the first argument the file itself. So then you can do whatever you want on this file, or let's say a list of users, or whatever you want, blog post. So next can be triggered like multiple times, like I was saying before, the TV channel, it would be, onNext will be called every time you have a new frame to render on the TV. So you can imagine for a TV channel, I guess it's about 50 or 60 frames per second. So it's a lot of like onNext events called per minute. And then you have 2 events that are actually terminal. So when either of these events is propagated, your observable will not emit events anymore after that. It's over. Like your observable is like kind of like dead. You will not receive any notification after that, and you can only receive either completed or like on error. You cannot receive both in the same time or like one after each other. It's not possible. You have only one of them, and then it's terminal. So uncompleted, what does that mean? It's like the observable is done and it will not emit notifications anymore. It's like you observe, like, all right, so I proceed your file. I usually, let's say the time frame would be like this. So let's say you have an observable fetching a file for you. It will first emit onNext with the file itself, and then it will emit uncompleted, telling you that, you know, it's over and you're not supposed to wait for more notifications because nothing else will happen. So you can, for example, unsubscribe after that. And on error, you might know what's happening. It's like a observable has been interrupted for whatever reason. Let's say you try to find the file and you didn't handle the exception correctly. So there is an error, the file hasn't been found. And this error is propagated by the observable, and the observable will not emit anymore. So you get to really start the action, for example, if you want to. You just ignore it, just display a pop-up to your user or whatever you are interested in doing. I've seen a question over there.
Oh, no.
Cool. Oh, okay, cool. Cool. Any question about the events? Does it make sense?
So can a cold observable permit just the completed, or should it permit that?
Okay, next is optional. Actually, all of them are optional. You can like, let's say hot observable will actually never emit completed or error because you will like keep propagating events until like, but like it depends on your implementation, what you expect. Usually cold observable is better to have uncompleted because you want to know when it's over. And you want to unsubscribe usually, because if you don't unsubscribe, let's say you were going to have like all the subscription everywhere in your application. So in JS, it would be a lot of memory leaks everywhere. So you might want to like collect them later. Like you're like, okay, this will not propagate data anymore, so I can unsubscribe safely from this observable.
So how is reactive programming different, say, than like promises in JavaScript? Or...
It's actually this same kind of stuff. It's like more advanced. Like we're gonna see like the tool I'm gonna introduce you tonight. You can do a lot of stuff. Like promises, like it's actually the same stuff. It's like asynchronous operations. But for example, a promise cannot, if I'm correct, like to do something like a hot observable, that would be complex. Usually it's more like for an asynchronous call. And for example, Redux is based on that they will like, we'll see later that it's usually a hot observable. You're gonna have examples, like just I'm introducing the basics and then examples. That usually the way I proceed. Cool. And that is a little bit advanced, but it's good to know. There is also a notion of like a subject. So subject is actually a little bit tricky. It's above observable and subject. Subscriber, sorry. Yeah, I did a mistake. So, and the subject is above observable and subscriber. So it can be seen as a relay. So if you have a reference to a subject, you can either subscribe from this subject or you can trigger events on it. So it's like a subject of like two kind of like channels of communication. The first one is for reading, like you subscribe from it and you're reading value coming from it. Or the other one is writing and you like push events on this channel of communication. So it's like, it's a relay basically, like an antenna outside or whatever. It's like receiving data and we'll keep propagating. It's like the same than the DNS server or whatever. When they don't know, like for example, what the resolution to do. I guess I have an example, but it's not a big deal if you don't understand what it is. It's like a little bit more advanced. It's not the first thing you usually need when you're doing reactive programming. Yeah, there will be an example, yeah. Cool, so I was talking about Reactive X, which is a tool that I've been, I guess, they created like maybe now 3 years ago. It's a project initiated by Microsoft because they created the MVVM, I mean, they didn't create the MVVM pattern, but it's like the most popular one there in C#. So they started this project like was originally only for C#, and then it was ported like to actually a bunch of languages. So now it's available for PHP, Ruby, JS, Java, Scala. I don't think Go, but like you have like about a dozen of languages that are supported: Swift, C++, whatever you're using. So you might be, whatever you're doing as a software engineer or developer, you might be interested in, just looking at it. And so what it does is like, on top of like having this observable, they have a composition pattern. So you can actually, they're offering a bunch of operators, as we're gonna see. Like you can do a bunch of mappings or like skipping some events, or this kind of stuff. So it's really interesting. And for multi-threading languages, they are like offering a very easy way to like manage like threading, like be like, oh, I want to run this operation in the background. I want to run this operation, let's say, on a different thread, on the same thread or whatever. But that is only for these kind of languages. So you can build the website. So yeah, I was saying it's multi-platform. It's open source, so very nice. If you have any problem, it's very well maintained. Usually you have like updates like every week. So, usually right now you have very smart people. I don't know for any kind of languages, but like for Java, like you have one of the main engineer from Facebook and one of the main engineer from Square working on it. You have a lot of like very smart people working on it. It's not like a random framework. So I really advise you to just like at least look at it and then like play with it. But we're gonna play with it tonight, and then I will talk about Redux itself. Yeah, so I was saying like you have a bunch of like chain operators we're gonna see. For example, mapping like an event. Let's say I receive like squares from my. It's usually they use shape and colors to describe events, but let's say I receive some squares from my observable. I want to change every square to a circle, for example. That would be an operation I can do easily. Let's say I transform like a user into an administrator or whatever. You can also merge like multiple of them. You can combine the latest one from two sources of data. You can do a bunch of like composition operations. And no setup needed. It's just you import the library, nothing else to do, so it's pretty easy. Cool. So there's a cool website I'm gonna use tonight for. It's really nice because it can show you the timeline of what's happening. So let's start with a simple example of how to use reactive programming with Rx. First, is that okay for everyone? Like, is there anyone like that makes any concept or anything, or something you want to talk about? All right, I take that for yes. Okay, cool. So let's say I'm gonna show the. Okay, so here's simple case. So before running the code, we're gonna talk about it. So here I define an observable. So forget about the Rx.observable. It's like in JS, for the module stuff. So here I define an observable on line 1, and then I subscribe to it, and I pass a function to this subscribe function. And when I create this observable, I create it from an array of 1, 2, 3, 4. So does anyone have like any idea what's happening over there, or what might be the output of this code, like when I'm going to run it? Gonna explain. That's correct. 1, 2, 3, 4. So in terms of like the events I said before, so you have on next, uncompleted, and on error. What would be the timeline, the time frame? I mean, like what would be like? Let's say if I was capable of like seeing what was happening, what do you think I will see? Like in terms of like, let's say. That's correct. So indeed, I will see if I run this code, we're gonna see that I see 4 on next events, which is gonna be containing like 1, 2, then 2, then 3, then 4, and then by default, this from array function will emit uncompleted as soon as like all the elements from the arrays from the original. This in the corner, this object, you can see like the 4 events. So the blue events are like what the observable is emitting, and the green one is like what the subscriber is receiving. So you receive 4 different events. You can even see like the time, which is not really useful here, but anyway. So you can see 4 events emitted by the observable and 4 events received by the subscriber. Cool? Awesome. That was the simple case. Let's do something tougher. So also in the future, when I will share the slides with you, by the way, at the end. It's usually what I do, so you don't need to take any notes. I mean, you can take notes, but I will send the slide at the end. So let's say now in the future, when you see subscriber, it would be this function just printing into the console. Okay. So if you see subscriber, the subscriber variable, it's just a function printing into the console. So let me. So we're gonna see how uncompleted works now. So let's say, so here, actually, yeah. So what's happening here? So uncompleted. So here you can see I'm creating an observable manually. So what does that mean? It's like with this create function. So when you create an observable manually, you call create, and then this function provides you a subscriber. You pass a function that accepts the subscriber, and then you can do whatever you want to subscriber. So here, what I want to do is like, as soon as someone subscribes to my observable, I want to call this first on next event with a string, and then there's a 1, and then I will call on completed, and then I will call on next again. Okay? So that's like the definition of my observable, and then I subscribe to it, and so subscribe actually, the first case, if I show it again, to make it simple. So the first case, I only pass one function to it. It's actually, this function is accepting like 3 callbacks. The 3 callbacks are, so the free function, accepting 3 function, the first one would be for handling the on events. The second one would be for ending the exceptions, and the third one would be for ending on the completed event. Okay? So you usually, sometimes you will just want to pass the first one, and it's enough for you, but sometimes you want to pass like more. So here I don't care about the errors, so I just pass like a null function that will be ignored by Rx, and the third function will be triggered only if there is an uncompleted event. Cool? So if we speak about the time frame again, like timeline, what do you think we're gonna see? Like as a subscriber. So if I print, like, you're gonna use console, so what am I supposed to see into the console in this situation?
Maybe hide what's completed.
Do that again?
Are we going to see hide what's up? Completed?
Yeah. And what about this one?
Well, it says uncompleted, so it might not get to that. You're, I don't know.
That sounds like a good assumption. Yeah.
Uncompleted, so
Yeah.
I assume that when it's uncompleted or when the function of console logs completed.
That is good. Anyone else like any other opinion on it? Well, it's kind of easy. There is written something like a tip, but anyway. Okay, I'm gonna observe that. I don't know if, yeah, paste it. So if I run again. So what's your name again?
John.
John. So John was right, indeed. What's happening here is like, see hi, of course, what's up, and then I emit uncompleted. So my subscriber, I have an extended subscriber which is observing completed events, so it will print completed as well. And then what I was saying before is like the observable is trying to observe, like I was saying before, the observable can still emit notifications, but then in the internal implementation of the subscriber, it will automatically figure if the subscriber wants to still see some events, which is not the case here anymore because you have already emitted uncompleted, which is a terminal event. So the stream is over and you will not receive anything anymore. You can actually see it in the time frame here. You have only 2 events. The time frame doesn't show the uncompleted, but it's only showing you on next. But that's it. And so also what I was saying before is like you can also observe that Rx is like kind of like chain operation. So you like, I could have like, actually we're gonna see very soon that I can pass more over there, but it's like always like chain like methods. So under the hood for your information, well, this is so you might have figured that when you go create, you return an observable. Well, in JavaScript, we don't have like type of things, but let's say in languages where like it's a static type languages, it would be an observable of, you will specify that here it's an observable of strings, or an observable of integers, or whatever you want. But here it would be an observable of strings. So in JS, technically, you can pass whatever, like let's say I could have passed an integer instead of WhatsApp. In other languages where it's like static type, it's not allowed. Obviously. Cool. So maybe you're wondering, what about if, let's say, I do something like this. So I create my observable. What about if I do something like this? So subscriber or what do you think is going to happen if I do something like this? So technically, what I'm trying to do here is like define this observable, and I'll define a second subscriber. I'm going to subscribe from a source of data. So do you think I'm gonna? What do you think? Like, what do you think I'm gonna see over here?
I will set the shelf twice. Once when you first subscribe, for the same from the subscriber. I will self again. Completed. Well,
Do you think that the second one is going to say sub to slash?
high, yeah.
Yeah.
So it'd be high and sub 2 dash high. So sub 2 dash.
That's good. Anyone else? Any other idea? Cool. Let's try. But I didn't do any typo.
Sub to,
You're right, but the thing is, like in GS, unfortunately, you don't have multiple threading, so it's like one after each other. So the thing is, like as soon as, because here you're subscribing first, so that will like trigger everything. There is no delay between the actions. Let's say I set up a timer or whatever, I would see a delay, but there is none here. So that's why you see I was completed, and then you subscribe, and it's replaying like the events for you. So something you gotta understand is like I said, like when you receive uncompleted, it's like this observable is dead for the subscriber. It's not dead for all the subscribers, except of course if it's hot. Like this one is cold and will replay the events when you subscribe to it. Let's say, yeah, if it's an asynchronous call, you can rerun this the asynchronous call. If you're watching TV and CNN is down, like of course, all the subscriber, no one will see anything else from this stream of data. Cool. So was talking of like chaining operations. So let's look at this one. Oops. So if I showed again, so that, for example, it's it would be a mapping. So mapping, I guess you've seen that if you're doing some Ruby, just pretty sure they have that using like what's the name of the tool? Backbone or whatever, or underscore. Mapping is like, it's a function accepting one argument and returning like just one outcome. So you're mapping something. And here, what do you think I'm gonna see when I'm running this one? Yeah, sounds good. So let's run this one. So indeed, so mapping. So basically, what you're doing here, what I was saying before, is like let's say from array will create an observable, and then as soon as you call map on it, you pass of course this function for it's a mapper. But then this function is also returning an observable. So it's what you can see on this time frame up there. So you can see there is a first observable. Maybe the line is not, there is a line, maybe not very visible from you guys, I mean, from your point of view, but there is basically a first stream of data, which is like the array. So you have 1, 2, 3, 4, and then you have the map that receive like these events, and these events will be transformed and then propagated to the subscriber. So we can imagine, of course, that we can have multiple chain of mapping, and they will add like multiple lines to our timeline up there, but we can verify very quickly. Let's say map function of. So you can see the outcome has changed, and you have like 2 chaining of mapping, and you can have more mappings if needed. So that's really cool with Reactive. It's like you can like map, like not map, but you can have like all these functions next after each other, and you can do a bunch of stuff. So let's say, I don't know, you're fetching something from let's say if you're using Ruby or whatever, fetching something from your database, then like a class that is a middleman between the view and something else can apply an operation without applying this version right now, it will apply the version like when the events are like coming, which is pretty cool. It's kind of like lazy programming. You're like, okay, you know, every time you meet a new user for the UI, I just need to know if it's, I don't know, I need to display in red and blue, and you can, you know, add this mapper to your stream of data. That is a simple example of a mapper. Then, what do you have? So you have a bunch of stuff. Oh yeah, so now we're gonna see a timer. Let me show you again. So a timer, you know, in JavaScript, you might have used set timeout or like set interval before. So they exist in Rx. So the one is named timer, the other one is named interval. And so that will, both of them will trigger an event after the, like let's say here it's like 3 seconds. The element they're gonna emit is actually just a 0. So that here, like if I look at the event, I will receive a 0, and interval would be the same. Interval might increment it, not 100% sure, but it's like just an integer for sure. Whoops. Here, wait 3 seconds, and I should see, yeah, done. Here I don't care about the element, and let me check, let's say, every second now I want to print the event just to be sure about what's emitted. Cool, it's actually incrementing, yeah, it's what it was. So it keeps, you know, incrementing. So it's a better way, you know, that because usually when you do a set interval, whatever, you know, it's kind of like sketchy to do that, and you get to manage, like it's returning something, you know, like it's returning an integer, like which is actually an ID, and you've got to use clear time interval later if you want to stop it. Whereas here you just like unsubscribe from it, you don't receive anything anymore, and Rx is very clean and will like clean the interval for you under the hood in the implementation. Yeah. Any question? Oh, a good feature then. Cool. What else? Oh, this one is the only one I can run in this tool online because I don't know why the skip. I guess they have the old version of like Rx. But for example, I was talking about like operators. So this you have, for example, take or like skip or skill while. So for example, a skip while would be a passive function that is actually a predicate. So here, you might know what's happening. It's I want skip while x is lower than 3. So I will actually ignore 1, 2, like basically 1, 2, 3, 4, 5 will be all emitted, but this guy will only receive after 3, so 4 and 5. You can imagine you can have take while like skip, for example, if skip exists and you have just an integer like the number of events you want to ignore. So let's say if you're expecting something special, the predicate can be useful. You have a bunch of like variables. I'm not gonna talk about all of them tonight particularly because yes, you have about 50 of them, maybe more. The list is pretty long.
Skip while like the filter function, or is it?
It's one, take while would be the opposite. So if I pass take while, we'll actually only see, well, I did a mistake, sorry. That's strictly, so I would see 3, 4, 5, and take while with the same predicate, I would only see 1, 2. Yeah, question. That was a question. Yeah. Yeah, if we visit the official website, I was saying, that would be a link at the end. You have about, yeah, you have like all of that. And then you have a super long list of like sub-operators. So you have a lot of stuff you can do. Basically, any operation you want to do and you don't like you, let's say, you know, at one point I show you this create, and actually create is pretty bad. Like you shouldn't use it if like you get to, if you're forced to use create, pretty sure there's a better way to use like operators because they have really advanced operators, so you can do whatever you want. Because create is actually kind of tricky because let's say some, basically when I say like here, when you call on next, it's call on next on the subscriber, and the default implementation of the subscriber in Rx will check if the subscriber didn't receive completed before or has subscribed or whatever. But let's say someone passes on implementation of subscriber, it can like ignore this, like it doesn't implement these things. So when you do that, you might like actually break some stuff. So it's better to use like the operators from the, I mean, even if creating one operator, better to use like the other operators than doing a manual create in Reactive program, I mean in Rx.
I missed maybe the introduction, but is the point supposed to see pure functions so that there's no side effects? That's why you do it.
You might have some side effects, like maybe you want to save something to the base, so it's like kind of like a side effect. You're persisting some data. It's not
just in that, when you pass something in, it's always gonna, that output is always gonna be the same. It's never gonna alter.
Oh, sorry, say that again?
It's kind of like pure, whatever functional programming. Whatever you put in is always gonna have.
Yeah, I know what you mean. It's just a different way of programming. It's like, okay, I don't care about the result right now. I might actually not want to run this operation in the background because I'm not going to subscribe to it. It's just a different way of programming. Okay. It's like this old pattern, like I guess it was the Hollywood pattern. It's like, don't call me, I will call you when I need it. So it's like basically, it's like just lazy. You're like defining an action using, for example, here create, that if I don't subscribe to it, that will never be run. Okay. I don't care about the, because I don't subscribe to it, I don't care about the outcome, so it's actually just some code and I will never run it. So it's a different way, and especially when you're multi-threading, it's better to have this kind of stuff because you can combine them, like you can have like multiple sources of data reading events at the same time. Like again, let's say multi-threading would be if I have two TVs in my home next to each other and I watch CNN and the other is like watching like HBO, for example. So I watch both of them at the same time and I'm like combining, or like I'm like one time like looking at CNN and then at HBO or something like that. So something a little bit more complex now is gonna talk about the flat map. Let me show the slide again. So flat map is a little bit more complex. So get to remember what I said before. So as what I said before is like every time you call these operators except subscribe, they're all creating an observable of something. They're creating here an observable of just integers that will be incremented for an interval. Take is a new one we haven't seen so far. So take is like a little bit like a what do they do? Take is a little bit like because some operators are not named the same like all the languages. So if I'm right, take is actually just what? Sorry, take is emitting 1, 2, 3. Well, here 3 would emit like 1, 2, 3 every time you call it. It's like from array 1, 2, 3. Okay. I'm gonna see the implementation. So, like it's just like emitting an integer. Just see it as an integer. But let's say now I want to combine with another function that returns also an observable. So map doesn't work. Like if we look at the map again, the map, you pass a function that return like a result like right now. Like it's not, you can actually return an observable, but here when you're gonna see, it's not an observable of integers. It would be an observable of integers. Like because you're like here it's a mapping function. You receive like some squares and you want to transform them immediately to circles. Here, what I'm talking about is I have a function, give me a square, and I will return you an observable of circles. So it might be, let's say, for 1 square, I transform you that into 2 circles or something like that. Or just 1. Like here, it would be fetching from the server, it would be actually 1 notification. So this one is a little bit like more complex. It's interesting. So So this function up there, fetch server, we'll look at it. It's a function that I just simulated like a call to a remote server. So it's like after 2 seconds, it will reach like, this function will emit like a 0. So what I'm doing is like, I don't care about the 0 that is emitted, and I will return integer plus 10, which integer is like the original argument to pass to this function. So if we look at this function, if I just subscribe to this guy over there, and I call it with like, let's say free, just fetch server, don't think about that right now, fetch server, I subscribe to this observable that is returning. After 2 seconds, I will see 13, okay? Is that okay until there? So if we look just at fetch server, don't look at that right now. Fetch server, after 2 seconds, I receive 13, and then I'm completed. Something we have seen before, nothing new. And then, so what I want to do is like, I want to actually fetch the server for every second with like 1, 2, 3. So I will call this function like actually with first with 1, then with 2, then with 3, and I subscribe to it. So I'm gonna run it. Maybe it's gonna be easier like that. I think I already pasted. Yeah. Up still work? Yeah. Sorry, I said a complete mistake. So for something else. Okay, so if I explain again, so the take 3 is actually taking only 3 events from that. Sorry for that. That actually makes sense. 4 was something else. Sorry for that. Sorry for the confusion. So just to sum up again, if I show you thing, every second emit like events, keep emitting events every second. I will only leave a free first notification from this guy, and for every of the notification, I want to run this operation that returns the observable. And eventually, at the end, I don't want to I want to see like a continuous stream of events. I don't want to like receive an observable, subscribe to it, and as soon as I'm done subscribing to the other one. It's not what I want to do. I want something simple, just one source of data. So it's what's happening here. Fortunately, there is no timeline, but basically, if we look at what's happening in the neighborhood, I see first like one notification here, which is 0. It's still good here. I take it. It's the first one. I call that guy, which wait 2 seconds, and after 2 seconds, return the original integer, which is 0, and a plus, and I just add 10 to it. So I see the 10. Then I will see like interval will emit in the same time. Interval will emit again an event. I take it because it's still cool. And I call the server again, which takes 2 seconds, and then I return the integer plus 10. Same again with 3 and 2, and then it's the last in the call fetch server because take 3 I said I'm only on the 3 of this. So if I run again a stream of data, I will see after 1 second, actually 3 seconds. So the first time the 10 appears after 3 seconds because it's 1 second plus 2 seconds over there, then 10. Then the same time, while I'm like fetching the server, and the one is emitted, kind of like queue and like waiting for it. So it was like, let's say after 3 seconds I get 10, after 4 I get 11, and after 5 seconds I get 12. Just run it again, and then I can answer questions. 3 seconds 10, then 4 seconds 11, 5 seconds 12. That was a little bit complex, so I expect questions, or you're awesome if you've got this one.
What's the difference between map and flat map?
So yeah, so just to sum up again, so a map is like I take a function receiving an event, and I just transform this event into a different event. But I can do whatever you want. I want something. I can return like an observable of something, like I can transform this element into an observable. But here, the problem is like, in terms of like typing, here I will receive like a source of data, which is not what I'm interested in. I want just to observe one source of data, okay? And so that's why it's called a flat map, because you map something, you apply a function, and you want to flatten it just after. You want to flatten the emissions into just a single source of emission. So here, this function fetcher, importantly, is returning an observable. It's not just a simple mapping function, just returning integer plus 10. It's returning like it's waiting for something. Here, I'm just fetching a server. It takes like 2 seconds. Awesome. Sorry for that. All right, we're back. So before, if I just apply a map, it would be just okay, a function has function integer and I return integer plus 10. But here it's a little bit more complex, returning a source of data and I get to subscribe to. But here on the subscriber, if I call just a map here and then a flat map, I will see an observable that will emit me like 3 observable of data that I need to subscribe them and to see 10, 11, 12.
Can we try to run it with this map?
Yeah, it's not gonna do anything. I mean, gonna see like observables. It's gonna do something, sorry, but not really good. So this like what you see here is like actually an observable object. So you subscribe to something, a function that returns you an observable. So, well, the console log is not very useful here, but technically what you see is an observable. But it's not what you want to do. You want to like see, at the end, you want to see 10, 11, and 12. You don't want to see
So are you merging the observables into an array that you have to subscribe?
it's more than that. It's just let me show you something simpler. I was maybe too ambitious with my example. So let's say I use flat map. So just one notification here. Forget the interval or whatever. I try to do a combination. Oh, cool. There is even the schema. So what's happening here? It's like, okay, I have an array, singleton array, just one element. Okay, I emit it, and using let's say in application can be okay, waiting for something from my database, and when my database provides me the result, I want to fetch like the picture of the user from the server, and then I want to return it to my view. Okay, so this function fetching picture from the server is something that I can observe. It's like okay, it takes 2 seconds to execute it, whatever, and we'll return the final picture. Okay. But the problem here is like my DB as well is returning me, before the flat map, is returning me an observable. So I want to combine it's not combining, actually it's more chaining these observables. As soon as one event is emitted from the first observable, I want to run the second one, and I want to flatten the emissions for offering my subscriber just like a simple observable. So you can see here, like you have, I guess this is representing an observable, so it's emitting one element, and the flat map is like flattening the emission. Let me, I think they have a F. It's basically when you want to use a map and you want to apply a function that returns an observable and not like just a simple element, you want to use flat map. So if I use so what I was saying before is like that is from the optional documentation, and like this is the observable, this is a subscriber, and like the bubbles, like the squares, are like the events. So here, what I want to do a flat map is like my function for every circle I receive with a bubble, I want to need 2 squares. It's something that I can observe, like this function. If I can subscribe to that, and let's say I pass a circle to it, I will see 2 squares. Okay, it's something you can extrapolate and use somewhere else. So here, I have a subscriber, and I don't want to see like, let's say, if I don't use flat map, first bubble return me an observable, so I get to subscribe to it, and as soon as I'm done, I need to change my subscription to this guy, which will return the same, and then to the third guy. I don't want to do that. Like as a subscriber, I'm like, okay, I just want to see like a single stream of emissions. Like I want to see a flattened. That's why it's called a flat map. It's like flattening emissions. So what's gonna happen here is like, okay, I'm calling flat map, and RX is kind of like doing this magic and will flatten the emissions. So you're just a subscriber and you see like this mapping operation perform. So you will see like for the bubble red, like 2 squares, and then you will see 2 green one and 2 blue one. Here they're like kind of like you receive the first blue one before the second one because they are too close, and we can imagine that here it's like there's kind of delay to meet like both, like they're not like just one after each other. So that's a flat map. That's still confusing, or that's better now? Anyone else who's like still confused about it? It's one of the tricky at the beginning, so it's going to be fine if you don't understand the first time or the second time. Basically, in your code base, if you have like you want to map a function that returns an observable, you're forced to use flat map. I mean, so like instantly in your brain, you should be like, oh, I want to map a function. I mean, I want to play a mapper that returns an observable. I'm pretty sure you want to use a flat map. That's cool. Let me check if they have this one on the. It's what I will share with you at the end. Nice. They don't have a flat map. Okay, they don't have a flat map. They have only a map. Okay. Maybe I can learn the function again. So what I was saying before is like, if I repaste the code originally, so we were like, array will from array will emit one event, and then the flat map will emit like this original event plus 10 2 seconds after. And my original example was like with timers in intervals.
Can you put like a second value in that array or
Which array?
The from array, can you get like one?
More values? Yep, sure. More values. Okay, 1, 2, 3. So 1, 2, 3 are like you can see like look at the time frame first. Yeah, so you can see instantly 1, 2, 3 are emitted. It's like the way from array works, and then there is this kind of delay when there is like they're all calling fetch server that takes 2 seconds to be run, and then they will be emitted later, and the emission will be flattened for the subscription. Because what I was saying before, if I just apply a map to from array, that will return basically this blue event. Like I will receive this one, that one, and this one, but not as like just integers, but like an observable of integers. So it means I get to subscribe to all of them. Like technically, I can show you actually. Oh, that might be. So here we also whoops, the flat map. So here with a map, the event I'm actually receiving here, event, it's not an integer. As we saw before, I showed you it was an object, like the console was putting like the curly brackets, which means it's an object in JS. So basically what you have to do here, if you want to see the integer, is like doing that. Can pass the subscriber directly. There we go. So with the map, the thing is like here, the events I'm receiving, events can be whatever, I said that before. Events can be string, integers, but they can be also observable. So it's like actually what's doing here, the fetch server is returning you an observable. So this observable you're receiving, if you want to see the 11, 12, 13, you get to subscribe to, then, to each of them, and then I'm using this original subscriber, which is just printing it to the console. So that might be not what you want to do. Usually you don't want to do that. You want to pass a subscriber, and you want to assume 11, 12, 13 directly. But as pictures and doing themselves doesn't work that way, except if you use a flat map. Makes sense now? Better with the mapping, I guess? Cool. That was like I guess one of the final examples. That was like the advanced one. Yeah. Cool. You can email me after the class, of course, if you have any question. And as I mentioned before, I will share the slide and all these resources with you, so you can check it out, everything. Cool. I think the last example it's the notion of subject I talked about before. You've heard that. So subject before, as I said, is a relay. So let's say here, I create my subject, and then by default, I'm not sure about the implementation in JS. By default, if I don't subscribe before many events, I will not receive them. You have different kind of like subjects in reactive programming. You can, Rex, you can define a subject that even if you subscribe after many events, you can like replay all these events. You have different like strategies of like basically subjects. But here, I guess it's the simple one. So you want to subscribe before, and then as soon as you subscribe, you're gonna like trigger events on it. And if you're going to assume the explanation correctly, you will see these 3 events, and then of course complete it. That is a subject. So subject is like the relay, so you can both read and write from it. So you can see here, I subscribe to the subject, then on the same object I subscribe to, I'm also emitting. So usually it's not the same guy subscribing and emitting. Of course, it would be like, let's say, a class will publish a subject you're subscribing to as a client, you observe what's happening, and this guy who publishes the subject will push events later. Yeah.
Is this old because you subscribe later and then it'll show up?
Yeah, what I was saying, I'm not sure about the original implementation. I think we can test right now, but you shouldn't see anything if it's the implementation I think about. You have basically you have different like implementation of subjects. I don't know how it works in JS, but by default it's not replaying anything. Like here you miss everything. If I'm correct, and I hope so. Yeah, you miss everything, so you subscribe late. Like you subscribe too late. Okay, the event already happened. Like you showed up at this party too late. Sorry, there is nothing to see anymore. But some of them are like, it's what they mean. There's a distinction between publish and behavior relays. Subject, sorry. So publish subject is actually the default one. It's like, if there is someone, I will notify it, if the one is not. But behavior subject will replay the latest event, I guess. And there is another one you can replay all. It's not the subject itself. It's like you have the operator named replay when you can replay like a full sequence of events. But by default, in the original implementation, I guess you have only 2 different kind of subjects. First one is publish, and the other one is which is default, and the other one is behavior, which will replay the last one. But maybe in JS they don't support that. I don't know. Yeah. Cool. Okay. So that was all for the examples that. And now I'm gonna talk about a little bit more like, okay, like I've introduced like all that stuff, like suggest and mapping and flat mapping and all that stuff, but now you're like, what am I supposed to do with that, dude? Like, how am I supposed to do that in my application? I'm going to talk about that right now. So let's say that is that doesn't work. Cool. Doesn't work. Sorry for that. All right. Nice. Are we back? I have no idea what's happening right now. I think we just lost the screen. Let me broadcast at the same time, which is cool. Sorry for that. Yeah, I was saying before, it's an application. So here we have like 4 components. So let's say you build like a mobile application website, it's the same stuff. So you get to imagine you have a client, which is usually like, so it's like I got to render some stuff. I'm the client. I need some data. Provide me some data. Or like I have interactions. I need to handle like, oh, my user clicked on the save button. What am I supposed to do? Convert the data to so then you have like what we call a service, and usually a service can be like, it's a generic term for like a lot of stuff. It can be a controller or whatever, where it's like handling a request from the client. Same before, user click on the save button in the website, it will like fetch a different like URL or whatever, or will send something to a controller, and the controller will appropriate to this input of that. I have a server, whatever server, something remotely. It can be a database, it can be another server, it can be whatever which is remote and not into your application. The service you need to interact with. And what we have here is like a repository. So a repository is like it's actually from the design patterns. It can be storage. A repo basically is storing in memory only, storing into a DB, storing into a file, storing into whatever. Session, DB, file. A repo is like something where you want to purchase some data and some implementation, but it's where you want to save some data. Like reactive programming. So how am I supposed to, because usually what I do is I have a client, I call on the service, I'm like, hey, user just save the form, do something with it. Server is like, okay, maybe I need something from the server, so you need to process something to, let's say server is a DB here, you need to save something into your database, and then you will return something to the client. It's usually this flow. It's like a two-way flow, okay? It's like you start, it's going back and forth, okay? But with reactive programming, you can change this way. What I was saying before is like client updates an item, the service, let's say controller is forwarding the update to, and the server, or like this entity you're trying to contact, return a confirmation of saving this data. What it's gonna change here is like the service is not going to return directly data to the client. Something to be repo. So here I said persist data, but as I mentioned before, repo is whatever. It's like memory, DB, file, session. You're just like pouring data to this guy, pouring directly the data to the client. And it's here. It's actually because it's super smart. So the client's like sending something and doesn't know where it happens, serving the repo only. So the client is only seeing the service in repo, and like here the repo is exposing some serve, like let's say the current user. So let's say here if I change the user, so something to the service that updates the DB, and then forward to this repo that is only hosting like observables. And to know that the current user has been updated, will observe a stream from this repo. You know, that there is the observe current user, which returns an observable of user, and you just subscribe from it from the client. The repo doesn't know about the client. The repo is just like, you know, somewhere into you. Say, it can be like, the client can be like, so let's say it's a web page, you will move to another web page, and the repo doesn't add knowledge about that. So let's say the client doesn't care about when it's done or whatever, just like move to the page, and the new client will subscribe to this repo, and let's say this is running into the background, it was a long update, then the new web page will receive the update. The system coming back and forth, you're just observing like every update. So we'd be like just observing like, you know, so the feed, for example, not to refresh the page, you just, you know, stay on the page and it will observe automatically. So the client is actually observing repo. If we matter, not sure if Facebook works this way, but I'm saying we'll only observe a repo, and it's not like the usual way would be, oh, you will, you know, call the client, asynchronous call to your website, or is there any new post, returns yes or no with the post, observing there, and then it's like the server running a job and updating the repo for you, and the client's like notifications. You're just changing the way these elements are like interacting with each other. The original pattern you might be using right now, it's like coming back and forth. Instead of doing that, you use this intermediate like gag. Anything like as soon as you call the service from the client, anything else, you're like, okay, I call my thing, your stuff in the background, I don't know what you're doing, and I don't care. Just notify me. Just like update the repo as soon as it's done, and I will see the notification. Way it's reactive. So here, when I say observe re-update, like here it's like the observable stuff. There it's just like calling function, nothing changed over there. Changing your architecture is like instead of like that, you're just observing the repo. So like too magic word for you, too complex. Just see it like as like a DB or whatever. Like you're observing directly the database, whatever.
To combine step 3 and 4 and have the server directly update the repo, and then the client sees the updates right away.
It's WhatsApp.
Because it looks like the server is going back to the service. We want persistent data. Persistent data right away. Changes in the repo. The client is going to.
Well, usually, actually, if you want to do perfect execution, usually what you would do is like the service doesn't know it's a repo. You will see that as like observers, listeners, you get to trigger when it's like done with a specific action. Just like run something that updates the current user, I need to notify my observers. The repo is just offering like a bunch of ways to a lot of stuff like this object, let's say in Ruby, whatever, JS, we'll have a bunch of methods like observe current user, but you can do like, as you know mapping, you can just observe current user name. And you will just like, let's say just one observable, which is the global user, but then you will have like mapping client. Then you can observe something very specific, like just the current age or something like that. Mapping into the client. And that, of course, would be a hub observable. That's what you can usually do without like arrays, for example. do only call observable, like, oh, I do an asynchronous call and I'll wait for the answer. Whereas this one is hot, like I observe something, like, you know, what I was saying before, it's like, here I might change to the web page and I subscribe again to this guy, but this guy is already like, it's not something that would need credit all the time. So you just subscribe to it. Any question, I guess? So, you know, for this way, it's like, what I want to show you is like using a hot. But of course, if it's like something you don't believe in, it's fine. Just, you can at least use observables the old way, the classic way with like call. I want to do an asynchronous call instead of like using the jQuery or whatever tool you're using for running an agent call. You use them, so you wrap that into an observable. Cool. And so yeah, as I sorry for that. I don't know if it's a Wi-Fi or just hey for that. What's up? Just like what you see here is not what I'm seeing. Yeah, I'm trying to Apple TV. Hold on. I guess we're gonna use the old way. Yes, and now it's back. Okay. If the broadcast is still here, awesome. Cool. So now, we're gonna talk about Reactive. So all that works. So it's based on what it's a pattern named a collector. So the way it works is you have a collector where you're gonna register like I don't know what's there's likely was updating functions. So it's what you're gonna register to this collector register. So basically, this function they will like it's like a massive switch. You're gonna be like, okay, if this collector like I register this register, and the register would be like, okay, if I receive this message, the message is like A, I want to apply this function. And this function will take the old state of the collector and return a new state. That's why it's named reducer. So you can register as many as you want, depending on like how many messages you want to support. And then of course, this collector will be used to emit messages that will trigger functions. So that's the way Redux works. So it's like a little bit like the subject I showed before. It's like you basically you register multiple subscribers that will react to a specific message and will transform the state of the collector. And then you provide the collector to your client that will use it to like do whatever it wants. So
is the collector kind of like the observable?
yeah, it's more like a subject because it's like the trigger. Yeah, it's an observable. Yeah, exactly.
Like the observable part of the subject.
Yes, that's correct. So to show you exactly from the original doc. So don't look at the bottom right now. So look at the top. So the top is actually in Redux. So you have like, yeah, I'm not gonna climb on that. So what you have is like actually here, not 100% sure the way to proceed, but basically you have this collector you're defining that you need to store in Redux. Collector is more like a general like word for this kind of stuff. So basically, it's the massive switch I was talking about. So these reducer functions are like actually, when it's a case, it's a reducer. So you register a function that will, depending on the specific message, return a new state of the collector. So here, the collector you're defining, if first you are registering this first reducer that will react to the increment message and return state plus 1 to your collector. So here it's a collector of integers, you might have figured, and then you are registering a second reducer, which is reacting to the decrement message and return state -1. And then you register a default one that will be like a fallback reducer that will be run all the time, that will return the state. So that's the definition of the collector or store in Redux. And so you pass in Redux, you pass the massive switch to your store, where you have registered like all your collectors. And then you subscribe to the store, and you just want to display the current state of the store. So basically, this subscriber will be triggered every time the state is updated. Make sense? Don't look at that. Look at that. So you define a collector, you register all your reducers, and then subscribe to them. And here, in our case, we don't want, you just want to display the new state after a reducer has been run into the console. So then they show you the way I was explaining subjects before. So you actually push a notification on this store collector. So here it's a dispatch keyword, and then you dispatch the message you want to dispatch. So here with the increment, and if we look at the console, it's initially it's 0. If you don't saw that, but so if you can see that or not. So you dispatch the increment message, and if we look at the console, we will see 1. Then, if I dispatch, there's a message which is the same increment into the console, I'm going to see 2. And eventually, if I display increment, we'll see 1 again. So that's the way it works. So it's like, sort of like you have the same concept on top of the collector thing. Like you're subscribing to something that you have no idea when this is going to be run. Like you're just subscribing to a source of data. You have no guarantee when you're going to receive notification on it. You might not receive any notification. And then later you push some events onto the source of data that will do some stuff under the hood and eventually propagate the update to the subscribers. See the question over there? The question? Cool. Is that clear for anyone? Any question about the way Redux works? That is from the official document. I didn't create anything for it. I was lazy for this one. But yeah, so just to sum up again, you create your collector, you register all your reducers, you eventually subscribe to it, it can be later. We saw that before, you can do that later. I think in Redux it's like, it will not, like, if I subscribe there, I will not see these guys. I'm like 90% sure of that. And then later, we dispatch messages. So it's a nice way to proceed. You will, like, let's say you're looking for, hey, what's triggering 1 into my console? Like, let's say here it's like propagating the day to DB. You're like, where is that happening? You have only one place to look for. You look into like the collector. You're like, okay, what's up? So like, oh, if I have increment, supposed to increment +1, or it's decrement just -1. And so you only look there and for like the actions, and then you feel like, okay, where is now, like where you are receiving updates, you look into the subscribe method. Yeah. So the same way it's reactive programming, you you're like subscribing to stuff, you don't know what's going to be executed, and you have the simulation of events. Here, it's what I said before, it's a hot observable, so you don't have like uncompleted, for example, will not be received. Like it keep like updating stuff. There is only on next in this situation. I'm not like an expert in Reactive, so I don't know the way. Let's say here you throw an exception, I don't know if it's gonna work. Pretty sure it will. If it's nice, if it's friendly with error, it will call. It will do that. It will ignore your update and call the default reducer. Like it will ignore the original message, I guess, or it will just crash and your tool is dead. Maybe. Yeah. So instead of dispatching like the objects themselves, you dispatch like messages. That's the way it works. You will never like push like integers over there. You will push like a named name that you have registered before. And if you have not, you will like go into this fallback case. Cool. And I guess that was my last slide. Yeah, then it's like just like resources, and I will you can take the links right now. We'll send it anyway the slides at the end of the class. So of course, if you didn't understand anything about presentation, like it's possible, I highly invite you to look at the what's the observer pattern, which is basically everything that is happening, like either reactive programming or like RX or like Redux. And then if you're more interested in Reactive X, I invite you to check out all the available they have. And there's like resources to manipulate that. And I didn't test the Redux official repo link, but for sure you can Google it. You can find it very easily. Yeah. That's it. Yeah, question.
Have you used RxJS with React? How will that do that?
No, I'm a mobile developer, unfortunately, so I'm more using Java. But for example, I mean, that is something we're chatting about because this, like the culture pattern is not something new, but Redux, like, reintroduced it, so it's kind of interesting, especially if you have a lot of messages transiting over your source of data. So this pattern would be nice. For me, React, if I'm correct, it's more like a way of like building applications. So I'm pretty sure you can, especially Redux is from Facebook as well. If I'm not saying anything stupid, yeah. So I'm pretty sure you can like combine both of them. It's just like this would be more for your backend, whereas React, if I'm correct, is more like for building your UI, and it's more like the control part. So I'm pretty sure you can combine both of them. Like what I was saying that before, like more for like background operations. Some people are using it also Redux. I don't know for Redux, but like let's say reactive programming for UI, like propagating, like I will have an observable of clicks, for example, or something like that. Again, for example, in Android, it's what we do. You can observe a click, or you can observe a touch, or whatever, and you use it with the UI instead of publishing like data object, like a user on HashiCorp or whatever. So yeah, it's more a way of programming. That this guy, pretty sure you can use it for UI as well. Like you basically, let's say you have a click listener on like NGS or whatever, like on click, you will publish like on click, and then there will be something triggered in the neighborhood for like maybe if it's a submit button, you want to save some data or whatever. So just something on top of it. It's not helping you building UI or anything. Any other question?
So have you encountered any performance problem with this observer? I've heard some, let me not say back end, I've heard some stuff that sometimes it can have like a performance hit.
Well, performance for sure, there is something you get to do. Well, in JS it's not a big deal, but in other languages it is. It's like you get to be careful of the subscriptions. You get to manage them, save them somewhere. Let's say if it's a part of the UI, if it's screen subscribing, let's say in Java, for example, you want absolutely to unsubscribe as soon as you've done with this screen, because otherwise you're gonna have like lots of these subscriptions leaking everywhere into your application. That would be performance issue. Then in terms of like, it's really fast. Like I don't have like in terms of speed, I don't have any complaint about it. The only problem usually, especially going from Java or like any type language, it's like when you have an exception on one of the observable, and it's an observable which is like kind of like in the middle of your application, you're gonna have a massive stack, like error stack. So it's tough sometimes to know what's happening, because I know there is usually there is one coming from Eric's itself at the beginning, so you can have like a massive like line of code, you don't need Thursday, and then you get to dig in to figure out what's happening. So it's like more error debugging, especially when they're all combined, because that will propagate like the error everywhere. Let's say you are doing a bunch of mapping functions, all of them will emit a notification. So it's like a waterfall system. So if one of the sources is like broken, it's gonna mess up all the way down. Although it's more like this kind of stuff. And then when you're observing multiple of them, of course, you might have like a problem. Or there's something also named back pressure, which is happening for UI, for example. Like I said, you can observe click is fine. If you observe touches, for example, on the screen or on the web page, that is not a good idea at all, because you're gonna have back pressure. And back pressure is gonna be like the observable doesn't have time to handle notification. So you're gonna have a queue that is gonna need to be created to be observable, and it will have like a massive queue that has to deal, and usually it will crash. All your applications will crash. Because I'm like feeding too much observable and doesn't have time to handle it correctly. That is named back pressure. And some operators in their Reactive X, like it specifies in them if they do support nicely back pressure or not. But you have like cool operators who maintain that. Like for example, if you want to ignore like too many clicks or whatever, you can do that by just a number of clicks or time. Like let's say you have an operator named debounce, and debounce will collect like all the clicks for like 1 second and will emit just the last one, for example. So you have like kind of stuff for gathering all this notification if needed. You have tons and tons of operators, so you have always something you need to. Even like the debounce, you have window, you have time spin, which are like kind of similar. Like window, for example, will emit something every 2 and let's say whatever the window is, like every 2 seconds it will emit an event. And if there is none, it will emit a special kind of notification or whatever. You have a lot of stuff. And it's also cool for something, let's say you work on a product or whatever, if you track analytics, obviously using observables are nice, because you have like operators where you can like observe a notification without really subscribing. So let's say you were a service, like whatever, like updating the database, and you want to save in the same time like an analytic event for your marketing team or whatever, you can do something that is named do on next on an observable, and that will allow you to run something every time there is a next notification, but it's not a subscription. Like if you don't subscribe to this callback you defined just before will not be called. It's just like you basically observe, like you like the word. Yeah, basically you're like observing any notification without like really capturing it. Like you're not like using, the final subscriber, you're just like observing them. That could be a great way to do stuff. Then you have a lot of cool stuff too. And that is very promising as well. I think it's a little bit like complex at the beginning. Yeah. Any other question? Awesome. Well, thank you all for coming. We appreciate it.